Hello again and welcome to yet another chemistry lesson. I'm glad you made it, and in this one we are going to look at how do we write reaction equations. Okay, how do we write reactions, the equations as well as the symbols that we use. Okay, so far I have been using quite a bit of visual demonstrations of what molecules look like, but that is very ineffective when we want to communicate what is happening. But just to show you an example, I said, for example, at a previous time that we had salt, table salt, which is sodium chloride, which is sodium. If the sodium is the smaller one, giving away an electron to chlorine. So we have sodium, the symbol Na, giving away an electron, giving it a positive charge, to chlorine, who now has an extra electron, giving it a negative charge. And because these two particles have opposite charges, they attract each other with a very strong force, creating a molecule, and this is a molecule. Now this molecule, from now on, instead of drawing it like this, I'm going to rather write it like this: sodium, okay, NaCl. Now in the molecule, the convention is to write the positive ion first. Remember, when a particle is charged, it's called an ion. This is a positive charge called a cation, and this is a negative charge called an anion. We start with the positive charge first. Okay, but then again we know that not all compounds, not all molecules are ionic bonds. So what about covalent bonds? Okay, in other words, when we have, as an example, we have water. Okay, we know water is an oxygen molecule and two hydrogen molecules. Okay, bonding. Oh, I want to make that a different color. Two hydrogen bonds. Okay, almost in this shape as well. And so we have our oxygen molecule, 6 valence electrons, and those 6 valence electrons shares one of the 6 with a hydrogen that returns the favor by sharing one of his, and does that twice again. Okay, so this is a covalent bond. We don't have ions necessarily in these ones. However, the convention is, and this is called the Hill system, okay, the Hill system says always write carbon first, then hydrogen, then the rest alphabetically. Okay, and you'll alphabetically, okay, seamlessly. You'll notice this is going to become quite important later when we do what is it? Sorry, the name escapes me. It's called organic chemistry. When we do organic chemistry, this is going to become very important, the Hill system, but we can apply it here. In this case, we will write our hydrogen first, okay, and since there are 2 hydrogens, we'll use a little subscript to indicate that there's 2 of them, and then we have 1 oxygen, and that 1 oxygen is written like that. Okay, so just another example of the Hill system in action. We'll look at methane. Okay, methane looks like this. Methane has a carbon atom. So we have a carbon atom, and then we have a hydrogen. A carbon has 4 valence electrons, and a hydrogen, and it will share those 4 valence electrons. Each of them will be shared with a hydrogen atom as well. Okay, so here's my 4 valence electrons, and the one from the hydrogen, another one from the hydrogen, another one from the hydrogen, another one, and one from the hydrogen. Okay, so that's how they interact. So this one will be written, if we use this convention, here the Hill system, we will start with our carbon. There's just one carbon in this molecule, and then we have our hydrogen, carbon, and then hydrogen, and since there's 4 hydrogen atoms in this molecule, we will call it carbon hydrogen 4. Okay, and this one is called methane, and you'll learn later how to actually assign the names. Okay, for now we're just going to look at the molecular formula. This is called the molecular formula. Okay, and the molecular formula literally just tells you in the molecule what atoms do we have in that molecule and how many of them do we have. Okay, let me give you another exception, or a few more exceptions to the Hill system. Okay, so it's not always the case that the Hill system works like that. We know already that ionic compounds are exceptions to the Hill system. If it's an ionic reaction, okay, then we will simply start with a cation and then the anion. Okay, however, most covalent bonds will work like this, but oxides, acids, and bases. Okay, now at this stage, this is a completely foreign language to you. You have no idea what I mean when I say oxides, acids, and bases. But in general, an oxide is a metal bonded to oxygen. Okay, and an example of that may be magnesium oxide or zinc oxide or iron oxide, and oxides will end on O. Okay, in other words, for the oxygen. So the name oxide will always be at the end of the word. So then we won't follow the Hill system. We'll start with our original, whatever type of oxide it is, and then oxygen at the end. Acids, you might think you know what acids are, but later we'll learn the formal definition of an acid. But an acid generally starts with H. Okay, now H in general, H, if it lends out its one electron that it has, a valence electron that it has, it will have a positive charge. So acids will usually be a cation, okay, bonded to an anion. So then we will have some anion here at the end. Okay, that's acids. Bases end with an OH. Okay, don't be too concerned about this. We'll do much more of this later on in the course. For now, these first two will be sufficient until we get to acids and bases and explain the naming conventions there. Okay, so that is how we write the molecular formula. I'm not going to say much more in this video. In the next video, we'll look at writing an equation that produces this molecular formula. Okay, so I'll see you in that one, and we'll also learn how to balance it in that video. Okay, see you later.